Hello everyone, welcome back to my channel. Today we'll be solving Leetcode problem 3306, count of substrings containing every vowel and k consonants. Okay, so the problem statement states you are given a substring, you are given a string word and non-negative integer k. Return the total number of substrings of word that contains every vowel and at least k consonants. Okay, now that let me go jump back to my editor and let me try to explain you with an example. So we have something called a e I o q q and k is equal to 1. Okay, now that I have to identify all the substrings which contain all the vowels. Okay, what are all vowels? We have a e I o u, right? These are the vowels I have. And the other criteria is basically I should have one consonant here. Okay, this is my criteria. So if any substring which satisfies these two criteria, that means it can be part of my solution. Okay, so if you see, is a is a substring, but it does not satisfy this criteria, these two criteria, so it's not part of my solution. The next substring is ae. Does it satisfies my criteria? No, it does not, so this is also not a valid substring. Okay, so next is aei. Does it satisfies my criteria? No, it does not, right? It does not have all the vowels and it does not have a consonant as well, so this is also not a valid substring. So the next substring is basically AEIOU. Does it contains all the vowels? No, it does not contain, so it's not a valid substring. Okay, next is AEIOU. It contains all the vowels but it does not contain the consonants, so this is also not a valid substring. Okay, so the next substring is AEIOU and Q. Okay, it contains all the vowels and a consonant, so it's a valid substring. So if I have a variable which is basically count, so till now I have one such substring which satisfies both the criteria. Okay, the okay, and the next substring is basically, can I have a e I o u? Can I have one more q? No, I cannot have both the q's here, right? Since it contains two consonants, so it's not a valid substring. Okay, so yeah, the next substring is basically e I o. Sorry, I can start with e, which is not a substring. Ei is not a substring. EIO is not a substring, so on and so forth, right? I can form all the substrings like this and I can check, and the next is basically to check like this, right? So yeah, so we have a strict constraint on the consonants, right? So instead of having the k number of consonants at instead of having exact instead of having exact consonants, we can actually relax our problem. Okay, instead of saying exact k consonants, we can at least we can rename the constraint to have at least k consonants. Okay, so if you have at least k consonants, okay, that means let's have a e I o u q. Okay, the moment I have identified a this substring which satisfies all vowels and at least k consonants, okay, it satisfies this criteria, right? It has all vowels and one consonant. So what all substrings can I form with this criteria is basically the length minus the index of this particular uh, character, the end of this particular substring. This would give you the substrings which satisfies this particular criteria. So a sub if I have a substring, uh, if I have a substring which has basically k at least k consonants, and if I know the number of substrings which can be formed with k plus 1, with k plus 1 consonants, okay, at least k plus 1 consonants, and if I know the number of substrings which can be formed with at least k consonants, right? So to basically know exactly k consonants, I can basically subtract the answer of k, at least k consonants minus the answer for k plus 1 consonant. So this is basically the idea, right? So we basically relax our problem statement to have at least k consonants, and we'll try to identify what is the solution for this particular problem statement, and we'll also identify what is the answer for to have at least k plus 1 consonants and all vowels, right? And then we'll try to subtract the answer for both the solutions, and then that would give us the exact k consonants. Okay, so to identify all vowels and k consonants, this problem is more or like similar to this particular problem. You can actually try this out, the number of substrings with all characters. Here, instead of saying all vowels, they have specified the 3 characters. Okay, so yeah, it's more or less the same problem. So the idea is pretty much same. As I mentioned, we'll first identify a window which will contain all the vowels and the consonants. Okay, we'll first identify a window which will contain all vowels and consonants. Once we identify the window, the answer would be the length minus index. So these many substrings I can form. Okay, the next is basically we'll basically increment my our left pointer, and we'll try to identify the next window which is actually valid, and then again adding this particular value to our solution would be the total number of substrings. We'll basically in this particular loop in the particular loop until this particular substring violates this criteria. Okay, so let's try to code it out. Okay, sorry, yeah, I don't know when I have basically shifted this. Okay, as I was mentioning, this problem is basically this is a similar problem which is actually equal to this particular problem statement containing all vowels and at least k consonants. Okay, instead of having at least k consonants, okay, this problem statement says it should have at least all these characters. Okay, so it's more or less a similar problem. You can try it out at your end, but let's jump back to the actual problem statement. Okay, so idea is to have the all vowels and at least k consonants. We'll try to solve both the problems, one with at least k consonants and one with at least k plus 1 consonants. Okay, so let's have a utility function which will tell me count substring this will basically tell at least k consonants. Okay, string word, and will also receive a k. Okay, whatever is the case, so it will tell at least to have those many consonants and all vowels. Okay, so the idea is to identify a window which will satisfy the criteria of all vowels and at least k consonants. To identify the window, let's have a 2 pointers called left and right initially to the start of the string. Okay, let's have int left is 0 and right is basically 0, and we also need the length of the string, which is word dot length. Let's try to store it here. Okay, so we'll basically our aim is to identify the window, right? So let's right cannot go beyond the length, so the as long as right is within the bound of the string, will perform certain action. Okay, this is what the action is. Okay, at every time we're gonna include the current character into so idea is to check whether it contains a particular substring contains all the vowels and k consonants, right? To identify this particular information, let's have a map. Okay, which is basically character and an integer, and which will basically tell the occurrences. Okay, new hash map, which will basically store the occurrences of the how many times a particular vowels were occurred, and how many consonants were occurred. Okay, so this will basically tell that part. Okay, so idea is to have identify whether the current character is vowel or not. So we should also have a utility function which will basically tell me is vowel, okay, which will basically take a character as an input and tell me whether it's a vowel or not. Okay, switch C, case A, E, I, O, U. So if any of these characters is passed to this particular function, then it has to tell it's a vowel, or else by default it will basically say any other. If it receives any other character, that means it's not a vowel, right? So I have a function which will tell me it's a vowel or not. Perfect. So once I know what is the current character, okay, so let's have a variable called write character which will basically store the character at the right index. Okay, so I have to check whether the current character is vowel or not. Accordingly, I have to include that particular character's occurrences here. I have to increment the corresponding character. Okay, so wherever I have vowels, I will straight away include the vowel in this occurrence, whereas for the consonants, right, I will basically, whenever I receive a consonant, right, I will basically increment the counter in my hash map in my occurrences against a character called C. Okay, so let me write it down. Let's see is basically, let's have a variable called C which will be included in the occurrences. Okay, if it is a vowel, if the current character is vowel, if the right character is vowel, that means I have to straight away include the vowel in my occurrence, right? If it is not a vowel, then I will have a dummy placeholder C which is a consonant in itself. So whenever I receive a consonant, I will actually increment the counter for this particular character. Okay, so we are actually not interested in what consonant it is, so I have just created a dummy character consonant to basically include the count in the same hash map itself instead of storing it separately. So that is the thought process. Okay, if it's a vowel, then I will basically include the vowel in my occurrences. Okay, occurrences dot put the character. Okay, then what should be the value against that particular character? Occurrences dot get or default. If it is for the first time, then I should include the value as 1. If the character was already part of my occurrences, then I will basically increment it by 1. Okay, so this is what it actually means. Okay, now that I have included my character in my occurrences, so I have to check whether it's a valid substring or not. Okay, so to check it's a valid substring, it should contain all vowels and at least k consonants. Okay, so let me write it down a function to identify it's a valid substring or not. So to identify whether it's a valid substring or not, I should basically take the occurrences array, which is basically storing the information, meta information of the substring, as well as I should also receive k, which will tell me the how many consonants that this particular substring should also include. Okay, if the occurrences of the consonants, okay, occurrences of the consonants, if it is less than k, okay, by default I need k characters, but if it is less than k, that means it's an invalid substring, right? And the other thing is I should also check for all the vowels. Okay, so let's have a variable called vowels which will basically have all the vowels: a, e, I, o, u. I have to basically iterate through my vowels array and then check if any of this vowel is not part of my occurrences. Okay, that means if any of these vowels is not part of my substring, Okay, then I have to straight away return it as false. Okay, that means it's not a valid substring. If it has reached the end of the particular function, that means it has encountered all the vowels, and it also has a consonant which has at least k or more than k. Okay, k consonants or more consonants. Okay, so as long as the substring is valid, okay, as long as the substring is valid, okay, to understand whether the substring is valid I have to pass this the occurrences. As long as it's valid, then I should actually include my, let's have a variable called count, which those many substrings can be part of my those many substrings will have this particular prefix. Okay, so the length minus right would be the would basically tell me the number of substrings which contain k consonants and uh, at least k consonants. Okay, those many substrings can be found, basically length minus right. Okay, so now that I have included my uh, the all the occurrences with those many vowels and consonants, the next thing is that I have to remove the my left character, right, and I have to check whether by removal of left character whether it will still form a valid string or not, and then I have to repeat this process, right. So what is the left character? It is basically word that character at left. Okay, so if it's a vowel, accordingly I have to make my action, right. Let's, if it's a vowel, then I have to decrement the count against the vowel. If it's not, if it's a consonant, then I have to decrement the count against the consonant. Okay, so occurrences dot put c occurrences dot get. I know for sure at this point of time the whatever character I am dealing with, it will be part of my occurrences array before. Okay, so I don't have to actually use the get or default, so I'm pretty much sure that it will be part of my occurrences hash map. Okay, so the next is to basically increment my left pointer and then check whether the newly formed substring is valid or not. If it's a valid, then again I have to increment the count and then repeat this process until and unless it breaks the criteria. Okay, so here I have to increment my right pointer, right. Okay, in the end I can simply return my count. Okay, so let's uh, define the data type as long and then return it. Okay, fine. Now that I have to return, as I mentioned, this function will basically tell me with at least k consonants, but the problem statement says exact k consonants. To get the exact k consonants, we have to uh, call the at least k function and then at least k plus 1 function, and we have to get the difference, right. So count substrings with word with at least k consonants, and count substring with k plus 1 consonants. Okay, so let's try to submit this solution. Okay, there is some, the variable c has been already defined here, so let's try to let's not define the variable. I can simply use the same variable. Okay, and then I can use it. So it also says cannot find a symbol occurrences, some typo again. Okay, let's try to correct the typo. Let's try to submit the solution. Okay, one test case got failed. Okay, that's weird. Okay, it's actually expecting 3, but our answer says 1. Okay, it should have one consonant. Okay, hmm Yeah, so the third test case was failing. So if you see, the idea is to increment the left pointer, not the left character. So once we exclude the left, once we exclude this particular character, we have to increment the left pointer so that it would reach here. So that's the thing. We have incremented the left pointer, and let's try to submit this. Yeah, it has satisfied the normal test cases. Let's try to submit it. It has also satisfied all the test cases. Okay. Yeah, I think uh, I, I tried my best to explain this particular problem. If you have any questions, do post it in the comment section. Okay, and do subscribe to my channel for more such coding videos. Thank you.